Hello and welcome to online math class. Today's section is section 5.1. And in this section, we will look at normal distribution and standard normal distribution. We will be looking at the differences and what exactly does that mean. Objectives, we're going to interpret a normal probability distribution. We will find areas under the standard normal curve. Let's go ahead and look at the properties of normal distribution. We talked about discrete random variable in section 4.1. Today we'll be looking at continuous random variable. A continuous random variable is something that you can plot infinite number of times on a number line. The word itself tells you it's continuous, like the hours you spent, the height or the volume of a gasoline tank. Let's look at the properties. A continuous probability distribution of any random variable x, the most important continuous probability distribution in statistics. So 90% of the data that we take will be a normal curve. It's going to be a continuous random variable, and it will represent or mimic the curve that you see on the screen, which is called a normal curve. The properties are the mean, the median, and the mode are equal. You will see that it is an inverted bell shape and it's called a normal curve. It is symmetric about the mean. So when you cut it exactly half on the mean, you will see both two equal sides. Total area under the normal curve is equal to 1. Normal curve approaches but never touches the x-axis. If you see here, it keeps going, but it never touches your x-axis. So the total area under the curve is 1. I have to pause a little bit here and talk more about it. If I ask you what's the maximum probability, you will say it's 100%. But if you have to give it to me in decimal, you will say it's 1. So that's exactly what the area under the curve is. So probability is nothing but the area under the curve. So we will be slowly using chapter 3 and chapter 4 knowledge and incorporating it into chapter 5. Mean and standard deviations. A normal distribution, so keep in mind the word normal distribution, can have any mean and any standard deviation, any positive mean and any positive standard deviation. The mean kind of gives you the line of symmetry, that is, the mean is exactly in the middle. The standard deviation describes the spread of the data. That means the more spread out it is, the more standard deviation you will have. In this case, you will see that it's not as spread out as the previous one, so they have less standard deviation. You see the standard deviation is 0.07, 0.7, but here the standard deviation is 1.5. All right, so let's look at the next one. Understanding the mean and standard deviation. So now if I ask you to take a minute, pause the video, and look at the graphs. I have two graphs here, A and B, both are my normal curves. And if I ask you which one has the greater mean, I'll cut exactly in half, right? Because that is going to be my mean. One is 15, one is 12. So definitely mean of A is greater than mean of B. Now if I ask you which one has greater standard deviation, let me pick a different color. I have B here, right, which is much more spread out, and I have A, which is not as spread out. So if you look at it, the more spread out graph has a greater standard deviation. So in this case, my B is a winner. All right, let's look at the next one. The standard normal distribution is a normal distribution with mean 0 and standard deviation 1. What does that mean? In the previous slide, we have seen a normal distribution. That means I can have any mean, any standard deviation. But when I use the word standard normal distribution, keep in mind your mean should be 0 and standard deviation should be 1. You look at it, this is a curve of a standard normal distribution. The mean is 0 standard deviation 1, standard deviation 1, standard deviation 1, standard deviation 1 on the other side. And again, the z-score, the z-value, this is nothing but your z-value. So technically what happens is you will be using your z-score to change your normal distribution into a standard normal distribution. So your z-score is used to change your normal to a standard normal. Okay, so let me pause here for a second, open up your assignments. So let me go ahead and start with the first question. The total area under your normal curve should be 1 because 100% probability, which is 1. So area under the normal curve is 1. Okay, next question. I am going to go ahead and work with question number 2 here. What they ask you is find the area of the shaded region, and they said the graph depicts a standard normal distribution. Keep in mind when you hear the word standard, the mean is 0 and standard deviation is 1. So what I want you all to do is I want you all to go ahead, open up the graph right here, follow with me, and you see that the shaded area is to the left. And what they have given me is my z-score. They gave me the z-score and they're asking me to find area under the curve. So you have to keep in mind the word area or the word probability. I'm just going to write PR, or the word percentage. They all mean the same. So keep in mind, if they say area, probability, or percentage, they're all the same. So let's go ahead and tackle this problem here. So what I would like to do, I want you to focus. Question help, StatCrunch. I open up my StatCrunch and I will go to stats, calculators, and I will scroll all the way down to my normal curve because I'm working with a normal curve. Okay, let me go ahead and expand this one for y'all. So there's certain things that you have to look into here. The first thing is this is a standard normal curve. How do I know? The mean is 0 and standard deviation is 1. Do you see the mean is 0, standard deviation is 1. And the way you read this is probability of x less than or equal to 0 is equal to 0.5. So this box right here gives you the area or probability or percentage. And this value right here is your z-score value. So you will always plug in your z-score here and you will get your area here. So let me go ahead and erase it. So you can see this is your z-score and this is your area or your probability. Keep in mind, the calculator is always defaulted to the left-hand side. So if I want to find the area to the right-hand side, all I have to do is greater than, and you will see the area is to the right-hand side. Let's say you forget to do something like this. All you have to do is put your mouse onto that particular block and it will tell you it's a reference value. Reference value means a z-score. And if you move your mouse to the other side, it will tell you probability. That means in this box, you will be looking for probability. You have to enter any value between 0 and 1. Now let's go ahead and take a look at what we have in our problem here. So we have a z-score. Like I said, you will go ahead and plug this z-score in this block and you'll find the respective area. So let me go ahead and do that. I'm trying to find the z-score here. I'm going to plug in my z-score, which is 0.23, and I'll compute. But wait a minute, they're asking me area to the left-hand side, and I'm giving them area to the right-hand side. So what do? I simply change my inequality. And you see that my area is 0.5909. Let me go ahead and check how many decimal places do they want. 4. Okay, so let me take 5 decimal places. Plug that in. So that becomes 1. There you go. Now you can go ahead and find with the same concept, but this is area to the right. So you have to change your inequality to greater than. Now look at this graph here. This one says it's not left, it's not right. I have 2 z-scores, so this is area in between. So how do I do that? Let me move this here. So when you click on the Between tab, do you see? It looks exactly the same. So what I will do is I will go ahead and plug in both my z-scores in the respective places. Okay? I'm going to go ahead and plug in and do that. So this is negative 0.8 and the other one is 0.9, and I compute. So here my area is 0.6408. Again, depending on how many decimal places they want. I think in this case they want 4 decimal places. I'm going to go ahead and do that. All right, so there you go. So the previous one was left side. This is in between. Now let me go ahead and look. This is again in between. Y'all can do this. Okay, so let me go ahead and look at problem number 7. It's exactly like problem number 2. I'm going to go ahead and you know what I'm going to do? I'm going to check the answer so I don't have to waste time plugging it in. In this one, this says find the area to the left. Actually, I'm going to do one to the right. To the left, to the right. Okay. So in this case, they said find the area to the right. Again, whichever tab is white, that's the tab you're in. So I'm going to go ahead and click standard because I want either left or right. So I'm going to go ahead, right is greater than, and I have to plug in my z-score. My z-score is negative 0.24, and I compute area to the right of the standard normal curve. Oh, I plugged in negative 2.04. No wonder I got a different answer. There you go. And now your answer matches. My area is exactly the same. So sometimes they ask you to the left, sometimes they ask you to the right. So please be careful what they're asking you. All right, so let me go ahead and look at the other problem that I want to do. Let's do problem 11. This is area in between. When they say between, where do you go? You click on Between tab, right? And you simply plug in your z-scores. My z-score is negative 0.73 and the other one is positive 0.73. And then I compute. And there you go. Voila, your answers match. Please make sure you check the right decimal places so you're giving them the right options and right numbers. All right, let's see which one do I want to do. I like to do problem number 12. Look what they're asking you. They're asking you the total area to the left and to the right. So there are 2 ways of doing it. They're asking you area to the left and area to the right. So what I would do is I would click on standard first. And let me go ahead and pick my pen tool. They said the total area. When they say total, you know, you'll have to add area to the left and area to the right. So your curve pretty much looks like this. They're asking you area to the left, sorry, that's the right, and area to the left. So you need to go ahead and add these two areas. So let me go ahead and do that. Let me show you how. I will first find either area to the left or area to the right. So I'm going to go ahead and plug in negative 2.77 and I get an area, which is, I'm going to go ahead and write that down, 0.0002, oops, that's an 8, 28. Now I want you all to note this one. This is 0.0028. Now look what happens when I change this area and make it to the right. I get the same exact area. So how do you calculate the total area? You can either find area to the left or area to the right and times it with 2. So this is simply 0. Oops, that's a point. 0, 0, 0, 2, 8 times, my mouse is not working today, times 2, which gives you 0.056. All right, so let me see if I can tackle any other questions here. Again, the same thing. They gave you the z-score. Instead of saying area, what are they saying now? They're saying the probability. So it's exactly the same. You will simply plug in your z-score, but now you're going to give them area to the left. So they can ask you as area or they can ask you as probability. It's exactly the same. Let's see. This is again area in between. Y'all can go ahead and do that. Area to the left, area to the right. That is area in between, area in between, area in between. I want to go ahead and do this problem. So this one, it's the same thing. What they're saying you is find the area to the left or to the right. So let me go ahead and open that. Oops, why is it not opening? Hold on, let me check here. Yep. So they're asking area to the left or area to the right. So when they say that, first of all, because it's already set up to the right, I'm going to go ahead and plug in 2.65. That's my z-score. And you see that, what do I have? Area to the right is 0.428. So they want area to the left for the same z-score and area to the right. If you see that, I have the same exact z values. So the easy way to do is either find area to the left or area to the right and simply times it with 2. So 0.004 times 2 is 0.008. Okay, once you're done with this one, I want you to go ahead and complete section 5.1, and I will be uploading more videos as we go.